Welcome to the webinar. In this webinar, we are going to introduce a new tool-based methodology for re-architecting applications from PowerBuilder, enterprise-scale applications, to ASP.NET MVC or Java-based web applications. We call this new methodology digital rewriting, which, as its name suggests, is an evolution of manual rewriting to computer-managed rewriting of applications. We will present the methodology and compare it to a manual rewrite via the 10 top digital how-tos to re-architect applications to new web, mobile, and cloud platforms. Let's start with some formalities. Please make sure that all phones have been muted. We will allow some time at the end of the webinar for your questions, so if you wish to place a question, please do so using the panel to the right of your screen. There will be 3 polls during the webinar, and we will be publishing those on our website shortly after the webinar is done. And this session is being recorded, and you will be able to access it later again on our website. Let me start by presenting myself and Gizmox Transposition. My name is Gil Shalit, and I'm Pre-Sales Director at Gizmox Transposition. I have about 15 years of legacy enterprise application modernization experience, both as a developer and as a pre-sales manager. But when I joined Gizmox over a year ago, I saw application modernization done right, and this is what we will be discussing today. So now I would like to introduce Gizmox Transposition. We have a strong R&D center led by a group of enthusiastic industry innovators who have introduced new products to refactor applications to mobile in the past. We have all experienced application modernization with traditional tools and found them insufficient for today's need to re-architect applications from old to new platforms. So we developed Gizmox Transposition technology to overcome the shortcomings of traditional solutions. Our delivery center, that is based on university graduates who are trained to operate Gizmox Transposition technology and support our partners. We are now in the process of scaling out to additional customers after completion of critical mission projects for several Fortune 500 companies. This is a partial list of some of the companies we've done projects with and some of our partners in the process. You can see companies in the healthcare sector, in finance, banking, and we should point out that we are partners with Microsoft to migrate applications to their modern .NET based desktop and web application platforms. So we will be arguing in this webinar that digital rewriting is the most efficient methodology to date for large systems to truly re-architect to a new platform. We will show how in 7 days we re-architected tens of thousands of lines of code into a cloud application with an HTML5 client and a mobile UI. Let's discuss the challenges in migrating a PowerBuilder application to the web. We need to migrate the desktop UI to a web-based UI. We need to re-architect the application to a web-based operational model. We need to include a native mobile experience in the migrated application. And last but not least, we would very much like to have an accurate upfront assessment of the time and cost which will be involved in migrating the application. So looking at a standard PowerBuilder architecture, let's see how the re-architecting is done. The data access becomes part of the data components in the data layer on the web or cloud server. The structures go to the model in the MVC part of the application. The NVOs become the business logic in the same layer. All the UI components go to the view. The window also becomes part of the view. And the data window is split between the MVC components, the model, controller, and view. We will see that when we look at the migrated application. We are now looking more specifically at re-architecting the data window, which obviously poses the biggest challenge in migrating away from PowerBuilder. Our guiding principle here is that there is no data window control, like there is in Jaguar, for example, but a standard partial view with a true model and controller based on standard web components. So again, the CRUD operations become data components on the web application. The table definitions become the model. The standard services go to the controller, and custom logic is added to the business logic layer. And then UI operations go to the rendering part of the view to be rendered on the client pages, and bands and controls also obviously become part of the view, and then the view is rendered either on a desktop browser or on a mobile browser, which gives us the mobile experience on the same code base in the migrated application. So let's start from the end and look at how a PowerBuilder desktop-based application is migrated to a web application, both on a regular browser and with other form factor experiences. So on the left we can see a regular screen-based PowerBuilder application with a few master detail reports, and on the right we can see the same application after being digitally rewritten to the web application with the same functionality preserved, the same master detail type of data display, the same reports available, which are data window based. We will see how that is handled shortly. Let's look now at the same type of migration going all the way to a tablet based form factor, and we can see that on the right. Again, with the same reports, the same master detail type of operation. All of this again is based on data window migration, which we will look at the details of that shortly. Let's now look at going all the way from a desktop-based PowerBuilder application to the mobile view. Again, the same application on the left, but a radically different view on the right, but we will see that this view is based on the exact same code base as the browser-based application is. Actually, it's the same application with different views, and we will look at how this is done in some detail shortly. All of this is done by modifying the original PowerBuilder desktop application code and digitally rewriting it to a web application, ASP.NET web application. You can see the desktop code and then the tablet and mobile code using different MVC views to deliver the different mobile form factor experiences, which we will look at in more detail shortly. And here's the question: do you think you could do such re-architecting in only 7 days? I would argue that only extracting the business logic and writing specifications would take much longer, let alone the actual application rewriting with the standard development tool. So let's see how we did it. Let's start with the 50,000 foot high overview of the digital rewrite methodology. We will then dive into how-tos of the digital rewrite versus manual rewrite. There are three major process components. Source application read and analyze, which is fully automatic. This component is also packaged as a standalone analyzer that you can freely download and run against your source application. The second component is a full-blown Visual Studio integrated IDE with tools for a software architect. I would like to emphasize the fact that the best driver of such a tool will be an experienced software architect that is able to communicate with the machine on the architectural level. We will review some of these re-architecting tools shortly. And the third component is the component that reassembles the application and generates the code for the new application. It is an automatic component as well. And now to the first how-to. How do we do reverse engineering with the digital rewrite methodology? This is a fully automatic phase. We have the reader, which analyzes an application in its physical location in minutes. It does it by creating a code graph representation of the application and by investigating that code graph. This is also known as an AST, an abstract semantic tree, and we will elaborate about it shortly. Just in a way of comparison, the manual reverse engineering would usually involve system analysts redefining and specifying the target application, which would be a lengthy and error-prone process, sometimes becoming almost impossible in cases where the application was written many years ago, or documentation is out of date, or the developers who have written it are no longer around, which all are very common scenarios with these legacy applications. So what is the AST and how are we using it to rebuild the application? The AST is like a blueprint for the application. It describes all the required aspects of the application for rebuilding it based on new components in the target environment. It describes the application components, the code patterns, the dependencies, the flow, the business logic, and application functionality in a way which is queryable by the tool. Once it is acquired, it becomes the blueprint and specification for rebuilding a new application. The blueprint is also available in forms or reports and for additional queries run by the architect driving the tool. Unlike in a manual rewrite, in which each error directly affects the final code, one of the basic principles of digital rewriting is working on intermediate code that enables iterations without affecting source or target code. The architect tools manipulate intermediate code, which results in there being no need for source application code freeze. The source application can continue to be maintained and extended during the rewrite period, and the upgrade code can be dropped during the final compilation phase and integrated into the rewrite process with the mapping rules that have been applied. The architect operator of the tools can do as many iterations as needed for code quality optimization, and when they are satisfied with the optimized code, the machine automatically renders the application components and generates the new application. We will see a demonstration of working on intermediate code shortly. So the next how-to is code refactoring, and that's a fundamental phase in any code rewrite. There are tools in the market to do manual refactoring, which require advanced skills to define the refactoring and usually require repeating every refactoring action on each instance. The digital refactoring tool guides the user through the refactoring needs by pointing them out with suggestions on how to refactor them, and then the principle of define once, apply on all occurrences is automatically applied by the machine. Unlike a manual rewrite in which you have to recreate everything from scratch, with the digital rewrite, you just map existing application objects to new ones. In a nutshell, this means mapping and replacing old source objects, code or functionality with the new ones in the target application. Most of the re-architecting tasks are done by mapping. So let's look at an example of creating a mapping rule according to the tool's suggestion and having it take effect wherever it is applicable across the application. We are now looking at the Transposition Studio Architect tools. In the Explorer, you can see all the PowerBuilder objects from the tutorial application loaded into the tool, and we can look at the loaded code, which we can see is pseudo.NET language, the intermediate code representation. Clicking on another object, we can hover over some of the PowerBuilder objects and see the mapping rules that were applied by the tool. So we can also look at one of those mapping rules in more detail, opening the properties, and we can see that the initial type is mapped to web type. So these are the mapping rules that are applied by the tool, mostly automatically, and some of them manually by the architect running the tool. The digital rewriter creates applications in standard target frameworks We are centering in this webinar on ASP.NET MVC, but it is important to note again that we are also able to create Java GWT web applications, very attractive solution also. It is a central tenet of the digital rewriter to use standard frameworks, web frameworks, modern web frameworks, and the solutions that are delivered to our customers are standard solutions in those frameworks and development tools, ready to be maintained and redeveloped by the client's IT team. All of the inherent qualities of those modern frameworks are delivered as part of the target solution. Primary amongst those is mobile views, which we will be looking at shortly. So let's look at a demonstration or a deeper dive into the structure of the MVC application that is delivered from the PowerBuilder tutorial application. We'll start by compiling and running the ASP.NET MVC solution in Visual Studio. You can see it running in the browser. Let's bring up the first report there. You can see a master detail type screen with two components, the master and detail data windows. And you can see we can do in-place updating, and the name was updated in the master from the detail. Let's bring up the second report there, and you can see again a display which is very similar to the one we had in PowerBuilder, and the numbers are formatted the same way they were in PowerBuilder. We'll return now to the first report and see that the lower detail data window has a drop-down data window which allows changing the state. Here's the ASP.NET MVC solution created from the PowerBuilder tutorial. We can see a standard MVC project structure with controllers, views, and models. And let's look at some of those views and models. Because of naming convention, we can look at either directory. So all the views, for example, starting with D, are partial views for the data windows. We, as you may recall, are not creating specific data window controls, but they are migrated to partial views. And then there are the menu views, which start with M, and the window views, which start with W. So we have a very well-ordered MVC structure coming out of the PowerBuilder objects. So let's look at the Windows view for the customer's report, and we can see that it accesses two data window partial views in the partial control tag. The first one is the list, the customer list, and the second one is the customer detail. So we have, for the master detail view, as in PowerBuilder, where there were two data windows for those two parts of the screen. Now we have in the window two partial views for the two data windows. If we take a look at the customer partial view, customers partial view, we see the different text fields and controls in that view, showing the detail in the master detail configuration, and we see the drop-down data window as a partial control. So we have a data window, a partial view containing a second data window partial view, the drop-down data window. So you can see on one hand having the complete functionality of PowerBuilder, but having it in absolutely native ASP.NET MVC features and partial views, making our point about using standard frameworks for the target of the web application migration. As we've seen in the previous demonstration, the sixth how-to is making sure that the data window functionality and business rules become a reusable object using standard features of the target framework. So we don't migrate the data window as part of the target window or screen on the website. The data windows all become what is the standard object, reusable object in ASP.NET MVC, the partial view, and those can be incorporated in more than one window view. So if a data window has been reused on the PowerBuilder legacy application, there's no problem at all to use the partial view that we created from the data window on more than one target view in the migrated application. But we do all this without creating a data window replacement control. Rather, we use the standard ASP.NET MVC features of creating a partial view. The number 7 how-to is enabling a mobile experience on the same code base, making use of the standard target framework capabilities. As we'll see shortly, this is absolutely part of the digital writers solution, using the mobile capabilities in ASP.NET MVC or in the Java GWT framework. In other cases, using standard routing to serve the different mobile views using the built-in switcher that we will show, and allowing the same code base, the same business logic to be the basis for the different form factor experiences. So all of this doing manually would be very lengthy and risky. So let's go look at a demo of the mobile capabilities and how they are achieved in the delivered solution. We'll start again by showing the application running in the browser, this time using the mobile emulator of Chrome, showing the mobile view. So we'll select a report, and you can see this is a radically changed experience with swiping and dynamic scrolling. Let's bring up the second report. As we've seen, the migrated application includes separate views for the mobile experience. This is achieved, as we've promised, by using standard features in the target framework, the ASP.NET MVC framework. So if we look at the list of views, we can see that there is a customer list data window view and a customer list data window view with Android in its name. This will include a different view than the standard view, and the framework knows to display the different views, the correct view, according to the agent that is accessing, the browser that is accessing the application, using the switcher in the global ASAX file. So we can have different view agents getting different views according to what we define. This can be separate views for all mobiles and all tablets, or we can break it down according to operating system, according to specific form factors. The sky's the limit in the granularity of what we can achieve here. So again, the mobile experience is added to the migrated application through absolutely standard features of the target framework. The number 8 how-to, the digital re-architecting feature, enables custom re-architecting of the application, such as creating a data layer or separating out services. The feature has two levels: identifying a code block or code blocks, and then defining operations on those blocks, as we will see in the coming demo. So in Transposition Studio, we can go to the Resolution Manager, which lists many operations suggested by the tool, driven by the complete code understanding. So the first two items are suggestions for block operations. We can click and go to the actual code, and we can see the two blocks, in this case single line blocks, which are suggested by the tool. We can then select them and apply, and the operations are undertaken by the tool. And then we can go and edit the rule and see the parameters of the code block. We can see we are doing an extract method with proxy, so there's going to be two layers created, and the names of the functions and new namespaces are listed in the rule. Going to the second block and again looking at it. So importantly, the parameters of the new functions that are created are identified automatically by the tool, which we can see when we are inspecting the migrated application. We can go to the data layer and see that there are two new functions created, and with the parameters inserted automatically. We can then go and see where this is referenced, and it is referenced in the business layer part of the new application. And then these two functions are referenced in the original code, as we can see when we click on the references. So all of this is done automatically for us by the tool, and we can see that the original code is replaced by a call to the new business layer and data layer. Application reassembly is the last stage in the digital rewriting process. I'm not sure we have an equivalent in the manual rewrite process. The closest might be compilation plus unit testing. The digital reassembly is obviously much faster than manual rewrite equivalent. The machine now renders all the different components and code modules into the new application. Program flow and functionality are all being recreated according to the original application blueprint. You may think of this feature as a robot that collects all separate parts, checks their integrity, and automatically builds all the parts of the puzzle into a complete picture. The progress bar of the reassembly process might be the best representation of what the tool does at this phase. If you can read it, it reports what it does. It starts by loading the AST and then applying the refactoring rules, reconstructing the environment, applying the mapping rules, constructing code, translating, restructuring the components, and then rendering the complete application in its new form. Now to the fun part, QA, which is not usually considered as fun, but it might be if rewrite is done digitally. Real-world statistics show that while with a manual rewrite you start with an average of 50 bugs per 1,000 lines, or in more realistic figures 50,000 bugs for each 100,000 lines, with the digital rewrite it would be 100 bugs for those same 100,000 lines. And most of these bugs will probably be addressable by refining rules with the same principle of define once and apply many, rather than manually fixing the same bugs across the application. An important feature of applications migrated with the digital rewriter is that they will contain security features at any level required by the specific use case. So rules can be written to modify current behaviors to new behaviors. Refactoring can be done to change older patterns to new patterns, and we can supply very high levels of security, again, to whichever specification that you may require. Digital rewriting is offered in a technology as a service model. There are modular phases that can be selected from and tangible deliverables at each milestone. The engagement model is flexible and can go from only rewriting the code to a full turnkey solution from us or from one of our partners. Let's discuss the digital rewrite project structure. An important feature of the digital rewrite is that because all the work is done through the creation of mapping rules, not by actually modifying the legacy code, the legacy application can be maintained almost up to the end of the project. A few weeks before the end of the rewrite, the final code is dropped, the mapping rules are applied, and the new application is assembled. So a digital rewrite is very freeze-friendly. The project starts with a setup phase where the legacy application is baselined for parallel testing with the migrated application. This phase also includes a deep analysis of the legacy application performed by the tool and the creation of a detailed rewrite plan which is signed off by the customer. The next phase is the assignment of all existing mapping rules and the creation of a compiling new application with limited functionality to demonstrate and to test the structure of the new application. The final rewrite phase is reached when all legacy objects are refactored and mapped, and a compiling application with full functionality is ready for QA. Because the new application will have web equivalent functionality with the legacy application, testing is straightforward, usually making use of the same test sequences and data as were used with the old application. After passing full QA, the application is now ready for acceptance testing. Now we would like to answer some of the questions that were asked during the webinar. I apologize in advance because we will probably not have the time to answer all of your questions on this live session. The rest of the questions will be answered by mail and published with the on-demand webinar on our site. So, the first question from John, who asks, what is your pricing model? Can you provide some idea of the time and price for a medium-sized PowerBuilder application conversion? Okay, so thank you, John, for the good question. Let me break my answer into three parts. We price the conversion per line of code so that the size of the application is the main metric for the pricing. But the price per line may vary according to the application complexity. As you may remember, the digital rewriter's main principle is to write once and apply many for the mapping rules. So it's a combination of the complexity and of the number of lines. We also offer a workload share model in which the customer undertakes some of the conversion phases. A good example would be QA. So if we take all of those factors into consideration, we might be looking at a guideline of between 50 US cents to $1.50 per line of code. And as for the execution time, again, it will depend on the same factors: complexity, delivery model, and application size. But as a guideline, we can say that 500,000 lines will take between 4 to 6 months. And here's the question, the second question coming from Mary. Can you explain again about how the data window is handled by your process? Thank you, Mary. Unlike with other paths to the web, with the Gizmox transposition digital rewrite, there is no data window control. This means that the programming paradigm is no longer tied to PowerBuilder, and that the migrated application is a best practices modern application. The data window code and UI can still be reused in multiple pages, and that is because we create a partial view with, as we have seen, a full complement of a true model and controller for each one of those that can be included in any page, or even actually, as we have seen in other data window views, just like what was possible in PowerBuilder. by the way, when migrating to Java, the data window becomes a widget, obviously. And here's a question from Frank. What can you say about the expected performance of the converted web application? Well, that's always an interesting question. The resulting performance is target framework dependent. So the digital rewriter delivers a native web application on a chosen framework, .NET or Java, and the performance of the converted application is going to be comparable to a well-written application on the chosen target, obviously also depending on hardware configurations. A question from Anand. What about UI upgrade and mobile flow and form factor related changes? So that is a good question, Anand. Yes, we do UI upgrades if a customer would like us to. It could be with the same functionality and a web upgraded UI, or even a completely new form factor and modified flow for mobile. So all of these are possible. Another question is from Jerry. What about enterprise governance and security of the new web application? So the way to answer this would be again that the converted application will be native to the target platform, and any standard or customer specific application security can be applied just as you would with a newly written application. Our recommendation would be to specify upfront the security features you would like to apply, so it can be incorporated during the digital rewrite process. Lynn asks about the maintenance and extension of the web application. So the answer is again that since we deliver a native application, it will be maintained and extended with the target framework standard tools. Visual Studio if the target is .NET web application, and Java standards tools if this is a Java-based application that we deliver. And here's another good question, probably the last one we can answer, from Roy. Roy asks whether Gizmox Transposition offers partnership programs for SIs. So yes, absolutely, Roy. You are welcome to get in touch with us, with Gizmox, and find out the details. We do offer customized programs for SIs. So, thank you all. The on-demand version of this webinar will be available on our website shortly. Thank you again.